So for number 5, we want to find the absolute extrema of the function on the closed interval. So when we're looking for the absolute extrema, we need to check the endpoints and critical numbers. So to find our critical numbers, we have to take the derivative of this. So our derivative of 3x to the 2/3 power would be 2x to the power of negative 1/3 minus 2. You could leave it like this, or if you want to rewrite it, it would be 2 over x to the 1/3 minus 2. To find our critical numbers, we want to set the derivative equal to 0, and we want to find where it's undefined or where it does not exist. So first, let's set it equal to 0 and solve. So when I add 2 to move it to the other side, I get 2 over, I'll call it the cubed root of x. Same thing. Doesn't matter how you leave it in your work. Is equal to 2. There's more than one way that you guys can work this out to solve. I would put it over 1 and then cross multiply just to get rid of the fractions. It's going to be easier to do the math when you get rid of the fractions. So we have 2 equals 2 times the cubed root of x. When I divide 2 on both sides, 2 divided by 2 would be 1. So 1 equals the cubed root of x. How do I get rid of the cubed root? Cube both sides. So x would equal 1. Perfect. So that's one of our critical numbers. The other critical number we find where it's undefined. Where would this be undefined? Awesome. If you have a fraction, set the denominator equal to 0 and solve. So if we cubed both sides, x equals 0. So it's undefined at x equals 0. So this would also be a critical number. So these are our 2 critical numbers. Yes. So if you have a fraction, you're looking for where in our equation here, we're looking for where it does not exist or where it's undefined. So if you have a fraction, set your denominator equal to 0 and solve. If you don't have a fraction, then it could be possible that you have nowhere where it's undefined, and that's fine. Then your critical numbers would just be where it equals 0. Question? Yeah, there's some in the web assigned, like this one, we're practicing that has a fraction, so if you see it tomorrow, you're prepared. But I think number 6, or there is a question on here where you don't have a fraction, so then you wouldn't get any critical numbers where it's undefined, but you would have critical numbers where your derivative equals 0. So this is our critical numbers, but the question's asking for absolute extrema. So we have to set up our little table, find our highest y values and our lowest y values. So for x's on the table, we're going to put our endpoints and our critical numbers. So -1, 0, and 1. Yes. So when we plug in -1, -1 to the 2/3 power would be 1. So we get 3 minus 2 times -1 would be plus 2. So we get 5. We plug in 0, we get 0. And when we plug in 1, this would be 3 minus 2, which would be 1.
You're plugging this in
Original function. So what's our highest y value that we have? 5. Perfect. So the point -1 comma 5 would be our maximum because it's the highest y value. What's our lowest y value? 0. So what would our minimum be? 0, 0. Perfect. So this would be our absolute extrema, our maximum and minimum. It is possible that you could have more than one maximum, could have more than one minimum if you had two of the same y values. For the quiz tomorrow, or test tomorrow, sorry. For the test, the Rolle's theorem question is going to have these same directions. So it's going to say, determine whether Rolle's theorem can be applied to f on the closed interval. If Rolle's theorem can be applied, find all the values of c in the open interval a to b such that f prime of c equals 0. So it's going to be the same directions that it has just like on WebAssign. So it kind of almost tells you what you need to do. We're finding the value of c such that f prime of c, so our derivative, equals 0. So there's three things that we have to check in order to use Rolle's theorems. We need to know if it's continuous on the closed interval. We need to know if it's differentiable on the open interval. And we need to know if f of a is equal to f of b. If one of these three things is not true, then we can't use Rolle's theorem. So let's check. Is it continuous from 0 to 5? Yeah, we don't have any fractions here, so it's not undefined anywhere, so it is continuous. Is it differentiable from 0 to 5? Let's take the derivative and find out. So our derivative would be negative 2x plus 5. Is it differentiable? Yeah. Finding if it's differentiable, just you're seeing if it's if the derivative is continuous on that interval. So it is differentiable from 0 to 5. Check. Yes.
So when would it not be continuous?
If, let's say we had 1 over x plus 1 on the interval from negative 10 to 10. What could x not equal here? X can't equal negative 1. Is negative 1 in our interval? Yes, it is. So this would be not continuous.
And what about for
Differentiable, well, if it's not continuous, you don't need to keep going. You could just say that it's not continuous. But if you took the derivative and the derivative wasn't continuous on the interval, then it would be not differentiable. Yeah, you could get something continuous but not differentiable. So if there's a couple examples that we've done in some of the homework, I think if we had something like x to the 2/3 power, this is continuous, but if we took the derivative 2/3 x to the power of negative 1/3, it's continuous, let's say on the interval, we'll do negative 10 to 10 again. It's continuous, but when we take the derivative, and we make it a little bit nicer, this would be 2 over 3 times the cubed root of x. What could x not be in our derivative here? 0. Is 0 in our interval? Yeah, so this is not differentiable. If our interval was from, let's say, 1 to 5, then it would be differentiable on that interval because 0 would not be in our interval. All right, so let's finish this question. We also have to make sure that f of a is equal to f of b. So a is 0 here and b is 5 because that's our interval. So if I plugged in 0, I would get 0. If I plug in 5, I would also get 0. So since f of a is equal to f of 0 is equal to f of 5, we can use Rolle's theorem. So we have to check and make sure all three things are true in order to use Rolle's theorem. Now with Rolle's theorem, we're finding where our derivative equals 0. So this is what we're trying to find. So we already took the derivative to find if it's differentiable. We just set that equal to 0 to find what value for c makes our derivative 0. Yeah.
So the
if the derivative's continuous. So when we solve here, we get negative 2x is equal to negative 5, divide by negative 2. So x is equal to 5/2. So this would be our value for C, or just our x value. So we'll do number 10. So it says determine whether the mean value theorem can be applied to f on the closed interval from a to b. It'll give you all of these directions. So it'll say if mean value theorem can be applied, find all the values of c on the open interval such that f prime of c is equal to our slope. So it'll give you the formula for mean value theorem. The directions will be exactly like this on the test. So mean value theorem, we have to check for two things. We need to see, is it continuous on the closed interval? So from 0 to 1 here. Is it differentiable on the open interval? And if it is, then we would need to find our slope using the slope formula.
These are the formulas for the other ones.
Yes. All right, so to find if it is continuous, let's look at our function. Is x cubed continuous? Yeah, we don't have a fraction, we don't have a square root, so it's continuous. Let's take the derivative and see if our derivative is continuous. Our derivative would be 3x squared. Is our derivative continuous? Yeah, so then it would be differentiable. So because it's continuous and it's differentiable, we can use mean value theorem. So we need to find our slope of the original function. Once we find that value, we set it equal to the derivative. So we want to find f of 1 minus f of 0 over 1 minus 0. When I plug 1 into my original function, notice it's just f of 1, not f prime of 1. We're plugging it into the original function. We would get 1. F of 0 would be 0 over 1 minus 0. So 1 over 1 would just be 1. So 1 is our slope. So we're going to take that and set it equal to the derivative. So when we divide both sides by 3, we get x squared is equal to 1/3. What would we do next? Take the square root of both sides. So x is equal to what? Plus or minus 1 over square root 3. Rationalize it if it needs to be rationalized. So for something like this, rationalize it. Multiply the top and the bottom by square root 3. So x is equal to plus or minus square root 3 over 3. We need to check to make sure it's in our interval. Is both positive square root 3 over 3 and negative square root 3 over 3 in our interval? No. So what would our answer be? Just the positive one, square root 3 over 3. So check to make sure it's in the interval. You guys can use a scientific calculator tomorrow if you want, but for something like this, I want the exact answer. Scientific calculator is really only going to help you for the related rates questions. Mm-hmm. One other thing, we didn't practice this, but make sure you know how to find the derivative of an absolute value. We'll do it real quick. So our derivative would be the inside, so x squared minus 1 over the absolute value, x squared minus 1. Times the derivative of the inside. What's the derivative of x squared minus 1? 2x. So that 2x would go to the top. You can distribute it if you want. You don't have to. Just leave it as 2x times x squared minus 1. How would we find our critical numbers here? This is a good one. Critical numbers, we set it equal to 0 and find where it's undefined. So to set it equal to 0, which part would we need to set equal to 0? The numerator. So our critical numbers would be 0 and what else? Plus or minus 1. And then to find where it's undefined, what would we need to do? Set the denominator equal to 0. So it would also be plus or minus 1. You don't have to relist them, but those would also be critical numbers. Make sure you check your interval when you're listing the critical numbers. If it says the critical numbers from 0 to 5, what would our critical numbers be? 0 and 1. Perfect. So if it gives you an interval and says find the critical numbers from this number to this number, just check your interval. It may not give you an interval for critical numbers. It just might say find all the critical numbers. Yes.
We don't have to find a derivative for that?
We found this was a derivative.
Oh.
Can you find like the maximum of this? The extrema.
To find our extrema, we have x and f of x. We would plug in, well, it would give us, we could say, I'll say from -1 to 1. So we would use our endpoints from -1 to 1 and our critical numbers, which our endpoints end up just repeating as critical numbers here, because I made this up. Then we'd plug it in. Where do we plug it into? The original. We would plug it into the original function. So when we plug in -1, we get 0. When I plug in 0, what do we get? 1. And when I plug in 1, I get 0. So what would be our maximum? 0, 1. And what would be our minimums? -1, 0, and 1, 0. All right, let's do the Rolle's theorem one here, number 12. So determine whether Rolle's theorem can be applied. If Rolle's theorem can be applied, we need to make sure that it is continuous, it's differentiable, and it is f of a equals f of b. So to see if it's continuous on our interval that we have here, can I plug in anything from -32 to 32 here? Yep, so it's continuous. To find if it's differentiable, we need to take the derivative. To see if it's continuous, you want to see, do you have a fraction? Do you have a square root? If you have x in the denominator of your fraction, x can't equal 0. But here we don't have a fraction. We kind of have a square root here because this would end up being the 5th root of x to the 4th power. But the 5th root, we can take the 5th root of a negative number. If it's an odd index, you can take the 5th root of a negative. Yeah, if you had something like the square root, let's just say the square root of x from -4 to 4. This would be not continuous because it doesn't exist if we plugged in -4. But the 5th root, you can take an odd index of a negative number. Let's see if it is differentiable. So let's find our derivative. This would be 4/5 times x to the power of -1/5. The derivative of 1 would just be 0, so that would go away. If we rewrote this a little bit neater, we'd have 4/5 times the 5th root of x. What could x not be here? X cannot be 0. Is 0 in our interval? Yes. So is it differentiable? No, it is not differentiable on our interval. Because it's undefined at 0, and 0 falls in our interval. If this question said from 0 to, or I guess, yeah, from 0 to 32, then it would be differentiable. Because we're checking to see if it's differentiable on the open interval.
But isn't 0 like, or no? If it's from 0 to 30?
If it's the open interval, is 0 included?
Oh.
No.
It has the brackets.
But you're seeing if it's continuous on the closed interval, differentiable on the open interval.
Okay.
So even if it has the brackets, you're seeing if it's differentiable on the open interval. There was a question like that from the 5.2 WebAssign that kind of tried to trick you. So this is not differentiable. So we can't use Rolle's theorem. So we're checking to see if it's continuous on the closed interval, but differentiable on the open interval. I changed the interval here just to show you guys an example from 0 to 32. X cannot equal 0, but it's still differentiable because it's the open interval. So this is not including 0 and 32
Oh.
because it's the open interval. So this would be differentiable from 0 to 32. That's not what the question asked, but just to show you guys.